All right, here we go. So let's start by highlighting a few key things. I want you to highlight the word derivative. And we talked about derivative is also slope. And what was that other fancy word from last week? Differentiation. All right, I'm going to add on to it. Another word for derivative is called velocity. So if I ever ask you to find the velocity, you're finding the derivative. And then the other word that you guys use quite often in Algebra 1 and also in physics, rate of change. So we have a lot of synonyms to replace derivatives. And the two main things that I'm going to worry about today is going to be average velocity. Everybody highlight that. And again, velocity is rate of change. Okay? The way I like to say rate of change or average velocity is AROC. Oh, let me get the right pen. It is AROC, meaning average rate of change. Average rate of change. So if you hear the phrase AROC, it is a usual acronym in calculus. Okay? Now here's our definition of AROC. If y'all remember rate of change, it was change in y over change in what? X. Okay? So let's write that out. y2 minus y1 over x2 minus x1. And the way we like to call this in calculus, it's called difference quotient. Difference quotient. And it is pretty obvious. I see a minus sign, hence the difference. I see a fraction bar, which is a quotient. Are we good with that? Okay? So if you see the phrase using the difference quotient, find blah, it'll be this formula. And again, that formula is nothing new, correct? It's strictly from Algebra 1. So let's actually apply that on example number 1. Okay, Vincent, let's read example number 1, please.
A billiard ball is dropped from a height of 100 feet. Its height in feet at time t seconds is s of t equals negative 16 t squared plus 100. Find the average velocity over the time interval 1 to 2.
All right, let's highlight a few things. The function obviously is very important. The phrase average velocity is also important, and also the interval. Again, the interval is not x comma y. It is the upper and lower bound of the x's. So let's go ahead and notate them. That's my x1 and x2. And for the average velocity, what was the acronym that I'm going to use? AROC. And this right here, S of t, is my position. Where are you, basically? The position of the ball. And I'm going to write it from left to right in a way that makes sense for the AP test. The way they want it is y2 minus y1. Since I gave you the function as S of t, the official way is S of 2 minus S of 1. And the 2 and the 1 is coming from the interval. All over x2 minus x1, which is 2 minus 1. Now, we already know 2 minus 1 is already 1, right? So let's go ahead and write that on the bottom. The next piece is where some of you guys may want to be lazy, but don't, because I'm going to allow y'all to use a Desmos on this one to type things in. So what we're going to do is, the first thing is going to be plugging in. Anywhere I see a t, plug in the 2. And after that, anywhere I see a t, plug in the 1. So here we go. Because I'm thinking ahead, let's start with the bracket. We have negative 16. 2 squared plus 100. Close the bracket. And on your Desmos or on your calculator, your bracket is parentheses. Minus another bracket. And that bracket is very important because sometimes there may be a binomial, trinomial, something greater than a monomial. So we may have to distribute. So we have negative 16, 1 squared plus 100. So what I want you to do, because we know divided by 1 is understood, on your Desmos calculator, everybody type this in mindlessly. Again, bracket is another set of parentheses. And it should give you a clean whole number that is a negative value. Since we're dropping the ball, it should be a negative. Was it a 2-digit? Negative 40. Very good. So let's write negative 48 feet per second. That value is very important that I'm going to compare in a little bit. All right, the next piece. So everyone's done on the computer at the moment. Let's all highlight the phrase instantaneous velocity. So if the average velocity was AROC, what do you think I might abbreviate for instantaneous velocity? IROC, very good. So here's my IROC. And when I'm giving you the IROC, I think it's actually easier because you can take the shortcut. IROC simply means what is a derivative using the rule? That's a derivative with the V. And just to kind of reiterate, the derivative at the instantaneous moment is as it approaches zero. As it gets smaller and smaller and smaller at that point, what is happening? And we're going to actually apply that on the next example. Okay. I don't care about all this junk. If that is scaring you, don't worry about it. I'm going to get to the meat of it. Okay, the next example. Okay, Zoe, let's read the next example out loud, please.
At time t equals 0, a diver jumps off the diving board that is 32 feet above the water. Her position is given by s of t equals negative 16t squared plus 16t plus 32.
So let's highlight the position, just like the previous one, is given to us. And then it says, when does she hit the water? Now, when it hits the water, typically the level is at y equals 0, right? When it hits the x-axis. So what I want you to write on this one, just to kind of understand that it's going to be when y equals 0. And we're going to actually use the calculator, which is on Desmos. Let's all type this in together. And I know we're used to f of x. You can use f of x, but I'm just going to mimic what I see on here. So I see s, and then open my parentheses, s of t. Where's my t? Y'all can type it faster because I don't have the whole keyboard, sadly. And then we have negative 16 t squared. And then we have plus 16t. And then we have plus 32. And I want to know when it's hitting the ground or the water. So it's got to be to the right of it, of the origin. Did y'all get a clean number of 2? Y'all see how much faster this was than the traditional calc? You're saving a lot of time on the AP test, okay? So we have on here, it's going to hit the water when time equals 2 seconds. 2 seconds. All right, the next portion. Kyle, let's read part B.
What is her velocity on here?
All right, let's highlight the velocity. So velocity is, what was it again? The derivative, okay? So I want to know what the velocity was at impact. So that means I'm going to write out the official way. So the velocity is v of t. But to find the velocity, I have to derive the original s of t, correct? So another way to write this would be s prime of t. You have to be comfortable toggling back and forth, okay? The velocity is the derivative of the original s of t, okay? So then, let's go ahead and derive it. What is negative 16 times 2? Negative 32. And then we have just t. We have the understood one. What about just 16t plus 16? Good so far? Okay? But it says, when does it hit the water? So from the previous question, we know, why am I writing over here? Oh, God. Oh, that should have gone right here. Did y'all realize that? Silly me. So we know it's going to hit the water at 2 seconds. So I'm going to plug it in. I'm going to plug in 2 into this guy over here. So when I do, I get negative 32 times 2 plus 16. You can type it on the calculator if you want. It should be pretty much the same answer as the previous one, right? And then you question yourself. It's kind of like when the answer is like B, 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 and then you go, oh, no. Did y'all get negative 48? Yeah. Okay, that's coincidence. Okay, everyone good on that? Okay. All right. Darius, go ahead and read part C.
What is her velocity equal to 0?
Okay, so let's highlight the important thing. Velocity equal to 0. So they're asking us when, so we're looking for the time, but let's go ahead and notate. V of t is equal to 0. So don't we already have the velocity equation that we already found right here on part B? So all I need to do is set that equal to 0. So this is going back to algebra 1. Negative 32t plus 16 is equal to 0. I hope you can subtract 16 and divide it by 32. It'll be a clean decimal fraction. And it's okay if you have to type this in. Did everyone get half? Okay, I'm going to show you what this means visually. Because I like things visually done just because it's hard to picture what's happening. So there's my diving board. And here's the water. Maybe I can add a shark, but I can't do that. So we dive into the water. So the velocity at 0. We know the velocity is basically the slope. The slope is 0 when it's changing directions, correct? So right up here, my slope is equal to 0 at specific point, 1/2, comma 0. So here's what you're going to write to make sure this makes sense. At t equals 0.5 seconds, the velocity is 0. Understand what the order pair means. Everyone good with that? All right. Moving on to the bottom one. Let's see. Brady, go ahead and read the next two questions on D.
What is her velocity at 1 second at 1.5 seconds?
Okay. So we're using the same velocity equation that we found on part B. So let's go ahead and write out. We have V of 1 is at negative 32 times a 1 plus 16. And then we have V of 1.5 is negative 32 times 1.5 plus 16. Oh, 16. V of 1 should be straightforward. Someone give me the value. Good, negative 16. The units do matter, feet per second. And maybe the 1.5, you want to rely on decimals for that one? It's also clean. Negative how many for the second piece? Negative 32 feet per second. So again, I'm going to kind of wrap this up on this page real quick. So if I asked you for the average rate of change, you're using y2 minus y1 over x2 minus x1. Give me a nod if you understood. If I asked you for the IROC instantaneous, you derive the original function and plug in the value. Good? Okay? All right. So also on your homework, it's going to ask you, I want you to compare the average rate of change and then the instantaneous. Your answer should be somewhat similar. Okay? Let's say your answer is 4.1 and the other one gives you 4. That's similar to me. If it's way off, you've done something wrong. Okay? And by the way, how many questions on the homework today? Anyone check? 3. That's it. I know. I was like, okay. All right. On the next page, let's talk about the higher order derivatives. And again, what is another word for derivative that we know now? Velocity. So I'm going to highlight this word and also write velocity right above it. And velocity means rate of change and so on. And we'll try to write all the synonyms in a little bit. All right. So let's kind of talk about after the first derivative. Y prime is pretty obvious. Double prime, triple prime, not bad, right? And then we like the function notation, not bad. And then we have the calculus notation. So dy over dx means first derivative. The next one's a little bit awkward. D squared y over dx squared is our second derivative. And I know some of you guys might be like judging the person that made this, going, why can't it be dy squared over dx squared? You didn't make calculus, right? Just got to go with it, okay? All right, so then moving on to the next one. As a reminder, what was a way to remember sine and cosine derivative from that story from last class? Snow who? Snow cone, and then no snow cone. We're going to apply that right here. So we have the original function is given, and it's asking us to find how many derivatives? 3 times. So we have the first one, f prime of x. All right, someone give me the first one. Something x to the what? 30 x to the 5th. Oh, what happened to my 5? I don't know. And I'm going to leave the minus 3. That could change. Derivative of sine is what? Cosine. Derivative of sine is cosine. Boom. Okay, let's find the next derivative. Double prime. Okay, what about the next piece? 30 times 5 is how many? 150. X to the what? 4. Again, I'm going to put minus 3 for now. What is the derivative of cosine alone? Negative, so make that a positive. Okay, my third derivative, f triple prime. Now multiply 150 and 4. How many? 600, x to the what? Third, and then we have plus, that could change. Derivative of sine is what? Cosine. Was that easy to do? Not bad. Okay? Let's do a quick review on what you should have known on 2.1 on the quiz. If you were like, ooh, I messed up big time, time to have like an aha moment. All right. Let's see. Callie, go ahead and read underneath the linear approximation the first 2 lines.
Given f of x equals x squared minus 11x plus 13, find the value of f of 1.1 without a calculator. Just kidding.
I know that was
Approximate
lame, I'm
values
sorry.
and derivatives, though.
All right. So we have f prime. The prime means to do what? Find the derivative. Let's do that real quick. So what is the derivative of x squared? 2x. What is the derivative of negative 11x? Minus 11. I'm going to box this and say this is my slope function. You could say this is my rate of change. It is my differentiation, and so on. Okay, part B, Kylene, let's read. Okay. If any regret on your quiz was this today, so let's kind of reiterate. Let's start off by highlighting tangent line. And let's write out the equation that you were given to you back in Algebra 1. It's our point slope formula. Y minus a y1. Someone finish the right side. The m, x minus x1. So let's see what I have so far. So far, I gave you a point, and I gave you one one of the coordinates. Did I give you the x or the y? The x is 1. So I need to manually find the next one in a little bit, and then I need to find what is my slope. So here I go. When you're finding the slope or the point, and the point of f of x is at negative 1, I have to use f of x function. That means I'm going to go back to the original, plug in the 1. Let's all do that. Let's plug in the 1 into that. We have 1 all squared minus 11 times 1 plus 13. You can type it on Desmos if you want. And it should give you a clean number of 1 digit, right? Positive what? 3. For my slope, I told you that's my slope function. So for my slope, we're going to use this right here. So we have f prime of x is 1. 2 times 1 minus 11. Should be a negative whole number, correct? Negative what? Negative 9. Now I have all the information. This is my x1 and y1. So let's plug it in. We have y minus the 3 is equal to negative 9 times x minus a 1. This is sufficient, but I'm going to give you 2 ways that might still be okay to use. I'm going to move the 3 over by saying negative 9, x minus 1 plus 3. That's also good. If that bothers you because it's not in slope-intercept form, you can go ahead and distribute and combine like terms and get negative 9x plus 12. They're all good. These are all good. Everyone good on that? Okay? All right. Oscar, go ahead and read part C. Okay? So equation of our tangent line. So our tangent line was part B. So we are going to plug this number in into one of these right here. I think I'm going to use the second one over here. You don't have to. So here I go. Y is equal to negative 9 times 1.1 minus 1 plus 3. And I'm going to do that inside first. Negative 9 times 0.1 plus 3, which gives me negative 0.9 plus 3. Okay, let's see if that's easy to evaluate. So 3 minus 1 is 2, right? But I'm not taking the whole thing, so it's 2 point how many? 2.1. Let's talk about what this looks like graphically. You don't have to sketch this if you don't want to, but I want to. So here I have a curve. And here I have a point of tangency, which is called the tangent line. So I'm going to highlight. This is my tangent line, and this is my original curve. And I'm also going to label because it does matter. This is the f of x. This is f prime of x. Oh, it's not f prime, that's a tangent line, silly me. That is a tangent line. Tangent line. Okay, let's talk about what's actually happening. So a while ago I said the point exists at 1, 3 on the tangent line. So I'm going to go ahead and say this point right here is going to be 1, 3. Do we all see that? Okay, the next one. The next one says at 1.1, I am now at 2.1. So would you agree 1.1 is slightly to the right of 1? Okay, slightly to the right on the tangent line right here. So that means this point right here is 1.1, 2.1. And then our last piece, Kyle, go ahead and read part D.
Evaluate f of 1.1 using the calculator and compare to the approximation.
Okay? It's asking us to go to the original graph, correct? The original graph is this right here. Let's plug it in. And I'm going to actually plug it in on part D. We have f of 1.1 is equal to 1.1 squared plus 11 times 1.1 plus 13. Okay, type that on your Desmos. You should get something in 2 decimal places to the right. Is that right? 2 point how many? Okay, let's see what that looks visually on the graph. So it's saying this is my curve. So on my curve, if I go right above 1.1, it is 2.11. So graphically, where the numbers stay does make sense, correct? It is a little bit above. So here's the idea. My tangent line, the straight line, is under approximation at 1.1 because it's underneath the original curve. Do we all see that? Okay? All right.